A special relationship that exists among complex numbers is something called the complex conjugate. The complex conjugate of a number, a plus bi, is a minus bi. Okay, it's the same two parts, but we just flip the sign on the imaginary part. Okay, and let me show you why this is a special relationship. We're going to take a number 2 minus 5i and multiply by its conjugate, 2 plus 5i. Okay, these are the same thing, just the imaginary part has a different sign. So let's go ahead and go through and do this. 2 times 2 is 4, and then 2 times 5i is 10i, and then negative 5i times 2 is negative 10i, and negative 5i times 5i is negative 25i squared. Now notice that we have a plus 10i and minus 10i. Those things cancel. So we have 5 and then minus 25i squared, but I squared is negative 1. So I've got, this is 4 plus 25, which is 29. We multiplied two complex numbers and ended up with a real number, 29. There's no i's here. This is why complex conjugates are so special, because if you take a complex number and multiply by its complex conjugate, you will get a real number. Now, we're going to be multiplying conjugates quite a bit, and I want you to see a little shortcut that we can do when multiplying conjugates. I'm going to go ahead and just take a generic a plus bi and multiply by its conjugate, a minus bi. So let's go through and work this out and see what happens. A times a is a squared. A times negative bi is negative abi. And bi times a is positive abi. And then bi times negative bi is negative b squared I squared. These middle terms cancel, and we have a squared minus b squared times I squared, which is negative 1. And that is, of course, a squared plus b squared. So this is a shortcut that you can use when you're multiplying a complex number by its complex conjugate. Okay, we're going to be doing it enough that it'll be worth it to remember this shortcut, that if you take a plus bi and multiply by its conjugate, you'll end up with a squared plus b squared.